Good morning. I'm Mrs. Brinton, for those of you who don't know me. Mr. Randa, Mr. Blyfus, and I, we invited two speakers today to help launch our final unit in climate change. The first speaker is Alan Anderson. He has a degree in wildlife management. He has a career as an executive for the Boy Scouts. You can stand up. And he's been working in climate change ever since 2012. Our second guest speaker is Bruce Moreland. He's a retired Air Force officer. A retired Mayo mathematician, and he's been working in climate change ever since 2013. Welcome.
All right. Thank you, everybody. What we're going to do is I'm going to start off with a little motivational discussion to set the stage so you'll know why this is really important. I'm going to tell you that I'm a retired mathematician from the Air Force and a retired statistician at the Mayo Clinic. So I'm a scientist in some sense of the word, or actually, as my friend tells me, I'm the guy that told the scientists what their data meant. I'm also a Republican, and I don't know if I can say that, so let's just say I'm in one of the political parties that's more conservative. And so when I was running for office, I used to stand in front of audiences and introduce myself, and I say, yeah, I did ballistic missile coding, and I did nuclear war codes, and nuclear winter, and all of that sort of stuff. Very interesting math. And I would then say, as a mathematician, my sound bites are like 10 minutes in a whiteboard. So I'm in a college one time talking to the Republican students, all 8 of them. And I said, so are there any questions? And the first question they asked me was, where are you on global warming? And I said, well, it's really simple. And I went to the board, and they let me have the whiteboard, and I drew a couple circles, and I said, this is the basic equations for what's going on to create ice ages. And I said in 1970s, I was really excited about ice ages. I was doing orbital mechanics anyway, and since ice ages were caused by Milankovitch cycles, I was really excited about that. But meanwhile, there was this other science going on, and then I drew another circle on the board, and it's a great big industrial CO2. And I said in 1750, we started a planet-wide experiment to see what happens if you release several hundred million years of sequestered carbon into the atmosphere over 325 years. And the answer is what we're going to talk about for the rest of today, which is global warming. And after I would give that speech, I would say, the question is, what solution can we use that gets across the political divide? And that's an important question. But to get you, I hope I've given you a little bit of motivation to understand that even as a conservative, I understand this and I can teach other conservatives. And that's an important aspect of what I'm doing right now, is I am part of the conservative caucus that's teaching this to conservative thinkers because it's a global problem. So with that, I'm going to give you to Alan.
Thank you, Bruce. We are going to cover a lot of science in a short time, and I apologize for a little bit of the speed, but it's briefly summarized on your handout. So we're going to jump right in, and as we go, we hope to have time for a Q&A towards the end of the presentation. So if you've got questions, please jot them down. So the weather outside on any given day is not climate. Climate is the averages of weather over decades and centuries. And what we're doing now is we're permanently shifting to a warmer climate. And one of the sobering things about climate change is that as we get warmer, that's the new normal for 1,000 years. There's no really going back, and so stopping it as soon as we can is why it's so urgent. So as you see here, and I'll see if my little pointer will work on the big screen, if this is the current nice climate that we've enjoyed for almost 10,000 years, and in which all of our civilization and agriculture developed, but now we're shifting the whole thing. So we'll still have cold, but there'll be less extreme cold. And we'll still have hot, but there'll be a lot more hot. And there'll be a whole new category of extremely hot weather. And that's the challenge that we face. So, according to the scientists, really everything is at risk in our future. The good news is, and the hopeful thing for all of you to remember, is that we can solve this problem, but we've got to get moving on it significantly. In all of these areas, wind and solar, nuclear, revenue neutral carbon fee and dividend, which is something that we'll talk about, advanced battery technology from Tesla. You know, they're making electric cars, but they're also building the largest factory under one roof in the world out near Reno, Nevada, where they're making giant batteries to store the electrical energy from solar and wind farms so that we can use it when the sun's not shining and the wind's not blowing. And electric cars, and Toyota is working on hydrogen fuel cell cars. They've already got them on the road. And the question is, can they bring the cost down, and can we figure out how to have filling stations? But the technology is already here. Well, something else that is already here is climate change is something that's not going to happen in the future. It's already beginning to happen now. It's torrential rains. I don't know if some of you are aware, but just in my backyard in the last 4 days, we've had 4 inches of rain, and that is a huge amount of rain for such a short period of time, and the farmers don't like it to come this fast. It creates a problem for them and a lot of erosion. We have something called blue sky flooding in low coastal cities. We'll talk more about that. In other areas, we have increased drought and forest fires in the western states. The fire season out west in the mountains and in California has grown by over a month in time every year, and the U.S. Forest Service is spending a disproportionate amount of their entire budget just fighting forest fires now out west. More frequent and hotter heat waves, rising insurance rates. A number of years ago, in our hometown of Northfield, we had a hailstorm come through and destroy everyone's roof, a lot of people's sidings. It broke windows and it destroyed every car sitting outside. The cost of that is enormous, and it's rising. A few years ago, Minnesota had the second highest claims rate or damage rate of any state in the union because of hail and flooding, and this is all becoming part of the new normal. And in the future, millions of climate refugees having to leave places that are either getting too dry or too hot or too wet on the coastal areas. So what's happening and how and why it's happening is not a political issue. It's a scientific issue, and it's been tragically politicized, but it's a scientific issue, and we need to look to the scientists to find out what we should be doing about it. And over 95% of working climate scientists, and that's an important distinction, because you'll hear sometimes people say there's not consensus among scientists. We'll talk more about that in a minute, but there is consensus among climate scientists. And they say that the planet is warming rapidly compared to the past. It's warming mainly because of rising carbon dioxide and other greenhouse gases, and that's coming mostly from burning fossil fuels, coal, oil, and natural gas. And the planet, as it increasingly warms, because the more CO2 we pump up, the warmer it's going to get, will have increasingly negative impacts on the planet and your future. And really the only way to prevent worse impacts from happening is to first arrest the emissions of CO2 and then bring them down as quickly as we can, and we'll talk more about that. But there's a lot of questions, frequently asked questions about climate change. It's changed before, maybe it's a natural cycle, and you'll hear that from folks. Maybe it's the sun. CO2 is just a trace gas. How could that possibly be making a difference? Is there scientific consensus? Are the temperature records reliable? Are the future projections of temperatures reliable? Maybe it's all a giant hoax and a conspiracy among all the world's scientists. And I've heard it's not warm since '98, or we're too small to impact the global climate. And we're going to talk about all of these things from the perspective of what the scientific consensus across the world currently is. So jumping right into it, Bruce mentioned earlier about the Milankovitch cycles. And this is kind of a 100,000-year cycle. This is, first of all, 800,000 years of records. And you might have heard them drilling in the Antarctic in Greenland and being able to parse out of the ice rings what the climate was like. Using oxygen isotopes, they can estimate the temperatures, they can estimate CO2 levels, whether there was volcanoes, because it's all packed in those thin layers of ice. And what they found, especially in the last 400,000 years, is there's a tremendously regular giant cycle. So yes, there are natural cycles. And if you look at these little peaks up here, these peaks are called interglacial warm periods. And this little bit of time here is the last 10,000 years. We're in an interglacial warm period, and all of our civilization and ag has developed right up here in this little warm period. They're typically 12 to 15,000 years long. We've been in this one for about 10,000 years. So if anything, on the natural cycle, we would be starting a really, really slow, like 1,000-year cooling. But that's not what's happening. So also CO2 levels. For the last 800,000 years, it rarely got above 280 parts per million. But now we've shot up and we're at 400 parts per million and rising of CO2 in the atmosphere. So we're way outside the natural cycle. Well, could it be the sun? The sun is the source of all the warmth in our world. But you see here that the sun and temperatures were kind of tracking together. The sun's irradiance kind of tracking together up until about 75. But in 75, the sun's irradiance actually started going down a little bit, but temperatures went up even faster. It's not the irradiance of the sun that's causing the warming. Well, what about carbon dioxide? Actually, even 160 years ago, scientists were already studying carbon dioxide. And in 1896, a Nobel Prize-winning physicist, through actual laboratory experiments, discovered that if you double the amount of CO2 from that previous 280 that I mentioned up to 560 parts per million, he estimated that just based on simple physics of the greenhouse effect and CO2 molecules in the atmosphere, that we would increase global temperatures by about 7 degrees Fahrenheit. And today, with supercomputers and thousands of expert climate scientists across the whole world, they estimate that if we increase it to 560, that it would be somewhere between 4 and 8 degrees Fahrenheit. So you can see that it was well enough understood 100 years ago to be pretty close to a good estimate. Scientists know a lot about CO2. And here's CO2 rising. It's been rising pretty steadily. We started measuring it seriously back in 1958 on a mountaintop in Hawaii. A good place to measure it, completely surrounded by the Pacific Ocean. And you can see here that it's just gone steadily upward as we pump more CO2 into the atmosphere by burning fossil fuels. And the Earth's energy balance really is quite well understood by scientists. Greenhouse gases like CO2 trap heat, and that makes it a livable planet. If we did not have that friendly layer of greenhouse gases that capture outgoing heat and re-radiate it back to the Earth, if we did not have that, we would be a frozen rock. So greenhouse gases are good. They make it a livable planet. But they're also powerful and long-lasting. So as we put more CO2 up and thicken the greenhouse gas layer, more outgoing heat is captured and re-radiated, and we upset the balance and start warming up the lower atmosphere, which is what we're doing. So in a simpler picture, here you see a thin layer and some of it being re-radiated back to the Earth to keep us warm. You could call this the natural situation. And here's our new thickened layer re-radiating more heat back to Earth. And scientists understand this very well. Among climate scientists, there is no debate about this at all. And so that warmth is impacting our planet. This is from NOAA, our National Oceanic and Atmospheric Administration, one of the 4 key scientific agencies in place specifically to advise our government. We have NOAA, NASA, the EPA, and the National Academy of Science. And their job is to be the experts and to advise our government. And all 4 of those agencies concur with everything I'm sharing with you today. And unfortunately, some of our leaders are not listening to our scientists. But here's what's happening. Since about 1910, you can see a pretty dramatic, steady rise. It's never been a straight line, had a little flat spot in here, but that is a trend that we don't want to stay on. This is 2015, which was by far the hottest year on record, and 2016, which is not on the chart, was even warmer. And our planet does not warm evenly, even though the global average is only an increase of only 1.8 degrees Fahrenheit. And there we have to pause and say, wait a minute, this is Minnesota, 20 below in the winter, 80 above in the summer. That's a 100-degree spread. How can 1.8 degrees make any difference? Well, it's 1.8 degrees on top of all the normals, and just that little bit is melting the ice everywhere. Sea levels are rising, the ocean is expanding through thermal expansion, and sea levels rising from that too. One of our challenges, though, is it doesn't warm evenly. So at the North Pole, it's 4 degrees, and that's melting the northern ice pack very rapidly. And here's a look at that. This is sea ice extent on the North Pole in millions of square kilometers, and you can see that it was pretty steady around 10 million square kilometers for the longest time. Here's carbon dioxide, as I mentioned earlier, the normal level kind of being at 280. But then we started burning coal and then oil and then natural gas. And as CO2 levels in the atmosphere rise, we warm the planet, the ice starts to melt, and we've actually melted about half of the northern ice cap. On our current rate of emissions, we're projected to go somewhere between 8 and 1,200 parts per million by the end of the century if we don't do anything. And here's the same chart that I showed you earlier with the 280 being there. We're currently up to 400, and we may get to between 800 and 1,200, and that would be an uncontrolled, irreversible experiment on our planet and our future, a place we don't want to go. One of the most important questions in all of this is there really scientific consensus? Because you hear from some people on TV and on the radio and so forth, well, the scientists can't even agree. And when we survey the public estimates that maybe it's 50-50, so we don't know who to believe. But actually that is misinformation being spread, and the reality is what's on this chart. Here's 5 different studies done by different people in different years of climate scientists. First study, second study, these 4 together, a third study, a fourth, and a fifth. These are the percentages of climate scientists who say it's us, and it's CO2, and it's an urgent problem, and we need action. And here are the folks who say, I don't think so, nothing to worry about. Now, if I get cancer and I go to the Mayo Clinic and I talk to 10 cancer specialists, oncologists, and 9 of them say, you have life-threatening cancer and you need immediate treatment, and one guy says, I think herbal tea and acupuncture will do it, I'm going to listen to the 9, not the 1. And another way to look at that is scientific publications. When a scientist writes a paper, he sends it out for peer review. He gets it back with suggestions for making it even better and more accurate, and then it gets published in a peer-reviewed scientific journal. And of the 14,000 scientific papers that are in any way related to climate change, 99.8% of those research papers agree that it's us and it's urgent. So is there scientific consensus? Don't let anybody tell you otherwise. Among climate scientists, there is absolutely strong consensus on this issue. And 197 countries met in Paris in December of 15, and they all agreed it's us and it's urgent. And we, 197 countries, commit that we're going to reduce our CO2 emissions. And that is the most countries of the world that have ever agreed on anything. And that's because all of them have scientists, and the science is clear. And then among US conservatives and businesses, some interesting comments. The American Petroleum Institute, in a report last year, says, few things threaten America's future prosperity more than climate change. On ExxonMobil's website, rising CO2 poses significant risk to our society. Shell oil, we need to get to net zero CO2 emissions by the end of the century. And currently, 17 House Republicans and 10 Senate Republicans have introduced legislation saying it's us and we need government action to solve this problem. Europe's 6 biggest oil companies, including Shell and BP, have actually asked for a carbon tax on their product. And you'd have to say, how is that possible? And the answer is they understand the science and they've got grandkids too. Their future world is at risk. Well, what about temperature records? Here's the last 1,000 years of reconstructed temperature records. And each colored line represents a separate team of scientists using a separate method, whether it's ice core rings or tree rings or lake or ocean sediment, to reconstruct the past temperatures for the last 1,000 years. And you can see that there's a lot of variety, but it's all between down 0.8 and about 0, a spread there of 0.8. And here we started doing temperature measurements, and by 2004 we were here, and by 2016 we're up here. We're way outside any of those natural averages. Well, what about future projections? I mean, the weathermen can barely predict next week's weather. How can we predict the climate down the road? And actually, climate's easier to predict because it's the big averages. And in 1980, which is about the middle of the graph right here, Dr. James Hansen and a team of scientists from NASA ran computer models, and what they do is they develop a computer model and then they run it backwards across the known temperature records to see if their model and their inputs can recreate the temperatures going backwards. And if it works backwards, then they have some confidence that it'll work going forward. And they projected in 1980, 30 years in advance of the end of this chart, the red and the blue lines. The very jagged line is the actual temperature, and the black line is the averages. Now, while scientists don't claim to get it exactly right, what they're trying to do is get the trend right. And you can see that 30 years in advance, their model was good enough to project where the trend was going. Well, could it be a giant hoax? We have a senator who, because he could throw a snowball in the Senate chamber, said, see, that proves that we don't have climate change. But of course, he's mistaken. There's no chance that all the climate scientists of the whole world would be in conspiracy together. They know that if they falsify data, other scientists like nothing better than to find their mistakes and prove them wrong. That's an embarrassment to them, and it builds the other guy's reputation. So the worst thing that they could do for their career is to falsify any data or results. And in the world today, the US has a National Academy of Science. Lots of countries have national academies of science. 100% of the world's national academies of science agree it's us and it's CO2, and we need to take action. Unfortunately, there is a well-funded effort to confuse and delay action. Not all, but some fossil fuel companies have funded climate change denial to protect their industry, confuse the public, which they're doing a pretty good job of, intimidate scientists, and prevent action. And here's an article just of one case back in 2015 of a guy who's a real scientist, but in fact being shown that he was getting corporate funds that he wasn't reporting to put out his reports that climate change was something we didn't need to worry about. And there's a great book which I've mentioned in the handout called The Merchants of Doubt. And it starts back in the tobacco wars days. And if you want to read an interesting, intriguing mystery story, an adventure story, this is a great book. It starts with a tobacco and it goes through acid rain and the ozone hole and up to date with climate change. And you discover that some of the exact same real scientists who worked for the tobacco companies are the same people working now on climate change denial. And here's an example of their work. I actually saw this chart during the November or the summer primary season put up by a politician at one of his meetings. And he said, you see, there's remote satellite sensing is a respected organization at a university that tracks temperatures, and this is their chart, and you can see that there's no warming. We've been flat for 18 years and 7 months. Nothing to worry about. Except if you look a little deeper, and all I did was Google RSS, and then you find that this is the real chart, and the creator of the chart, the guy who's doing the research, is a guy named Dr. Carl Mears. He's the senior scientist at RSS, and he says, my data clearly shows a warming trend, and my chart is frequently used and misrepresented. So, if you look at this high peak right here, and that little swiggle right there, you can see that from there to there, it's still an uphill trend. But on that chart, they not only just cut off both ends, but they actually have to tilt the left end of the chart up to make it look flat. So there's actually a specific effort to keep the public confused. This is the real chart, warming is happening, and we need to be listening to the scientists. So about 90% of the heat that's been trapped in the atmosphere is being absorbed by the oceans. And the oceans are warming. This is a temperature record of the heat being absorbed into the oceans. And you might have read recently about the fact that across the whole world, coral reefs are bleaching. And they expel the algae that lives in them in a symbiotic relationship. And it's kind of the first stage of them dying if it keeps happening. And as the oceans warm, they're bleaching in a lot of different places. Well, as the oceans warm and as ice melts with thermal expansion of water and the melting ice, sea levels are rising. Projections are somewhere from 2 to 4 feet rise by the end of the century. And that doesn't sound like a lot, but think about the fact that for about the last 150 years, it only went up 7 inches. All of a sudden now we're on a fast rise. Our coastlines have been stable for decades and even centuries, and we've built right up on the coastlines, of course. So just as little as a 2-foot rise is going to be catastrophic for a lot of coastal cities. It's a place we don't want to go. Places are already having what we call blue sky flooding. And that's when you have the sun and the moon line up to create a king tide, an extra high tide, and seawater gushes up the storm sewers and floods streets and neighborhoods. And this is Miami Beach on a sunny day during a king tide. No wind, no storm, just seawater coming up. And that's beginning to impact property values. Well, is it possible that we humans are too small to impact the global atmosphere? And of course, I showed you that for the CO2 is higher than at any time in the last 800,000 years. That's us. We were burning a hole in the ozone layer. That was us. And we did the right thing. We listened to the scientists. We had an international treaty to reduce chlorofluorocarbons. And today, the ozone hole is still there, but it's very slowly healing. So global action to solve the problem, listening to the scientists, can get us where we need to go. We've overfished the oceans. We're cutting down the rainforests. These things can be reversed if we listen to the scientists. Well, some folks say, yes, climate change is happening, but we'll adapt. And that's easy for us adults to say because we won't be here. We should not be leaving the tough part of the adapting to you all. We should be taking action now so that all these negative things don't happen. So it's a real problem. It's unprecedented in human history, and we need to figure out how we're going to respond. And my wife reminds me that this is really serious stuff. You need a cartoon, so here's my cartoon. This is a climate summit, and the guy at the speaker is explaining all of the good things that will happen if we shift away from fossil fuels to renewable energy. And the guy in the back is saying, what if it's all a big hoax and we make a better world for nothing? So the choices that we make today will have different outcomes. We probably have a little warming built into the pie if we even take substantial reductions in CO2 now, but if we do nothing, we're really going to heat the planet up much warmer than it already is, and that will be the new permanent. It's a place we don't want to go. And it won't be the end of the world, but it could be the end of the world and the end of coastlines as we know them. So is there any good news? Yes, there is good news. 197 countries have acknowledged the problem and are working to reduce their CO2 levels. And actually, late breaking news this week, China and India are both ahead of us now in driving down their CO2 emissions. China canceled 110 coal-fired power plants, the worst source of CO2 emissions, and India is making big strides now also. Fossil fuel companies understand, a lot of them, and agree that we should have a carbon fee and dividend on their product. New solar and wind are growing exponentially. The US and China, who are the two biggest emitters, have had an agreement just between those two countries, I hope one that we can keep. And since 2014, 5 times more people work just in solar and wind than in all of coal mining. So the transition to renewable energy is a job creator, but there's a lot more that we need to do. We need to stop burning coal as fast as we can. We need to dramatically reduce the use of other fossil fuels, and we need to improve ag and agriculture. It's a big and daunting challenge. And that's an important one, but it actually encapsulates our big challenge. There's a lot to do in each of these areas. So it is a big and daunting challenge. We're going to be the, what? What? Oh. It's a big and daunting challenge. We are the last generation of adults, or we're the first generation of adults to really understand the problem. And we're going to be the last generation that has a chance to preserve the friendly climate that we've had, because wherever we get to when we level off is going to be the new permanent for about 1,000 years. Yeah. Nobody can do everything, but everybody can do something. You don't need to write these things down. They're all on the handout. You can get involved, join groups, write to your congressman, get yourself educated, help reduce your family's own carbon emissions, and courteously challenge skeptics. I think a lot of you might have a smartphone. There's a great app that doesn't cost any money, simply called Skeptical Science. And it's a great app that provides almost all the information I've given you. We need to take responsible action and not listen to those who tell us that everything is fine. So let's take that responsible action. Questions? And before we hit questions, let me give Bruce a chance to do any encapsulation there.
I just want to point out something that as a mathematician, I see a lot of these graphs that he's showing, and by understanding the underlying math, I get really nervous because it's scary what he just covered. It's as if we suddenly discover that humans have just learned that there's a thermostat for the planet, and we're the ones that control it now. And once you learn that, you can't go back. So, questions?
Okay, I didn't really get the part about the Earth's energy balance. Like you showed me, like the CO2 and like something else that helps
Right.
the temperature.
We have solar energy coming in every day, and in the past, we had an energy balance where the amount of sunlight reaching the Earth was balanced with the amount of energy getting out. And so we had kind of a rotation of warmth under our CO2 blanket, but a balance of what's coming in and what's escaping, but we have kind of a circle of warm air under the blanket of greenhouse gases, making it a warm and livable planet. The question is, why are there some scientists that say that it's something we don't have to worry about? And unfortunately, as I mentioned in that book, The Merchants of Doubt, there are industries that are trying to protect their own industry by denying it. And there are people who they simply don't want to study the science, or they only study one side of the science. And if you only look at bloggers, the bloggers will tell you there's nothing to worry about. But if you listen to the science and the scientists, and you listen to our NOAA, NASA, the EPA, and the National Academy of Science, they all tell you that there really isn't any question.
What data do you use to model the equations for climate change?
What I did was I put up one circle that represented the Milankovitch cycles, which are orbital mechanics. Like I said, I was really excited about those. And I said that circle represents equations that drive temperature. So the next circle that I drew was a temperature circle. And then I said, as it happens, as the planet warms up, the CO2 is driven, you get more CO2. And if you looked at those curves that he had for the 800,000 years, and I don't know if I can find them quickly, it turns out that temperature actually precedes CO2 by about 700 years. So those peaks that you saw in the CO2 are 700 years behind the peaks in temperature, because temperature was driving the CO2. Then, when I put in the next equation for industrial CO2 release from the experiment that I described, that changes the dynamic to where now CO2 is leading and temperature is following. And it's because CO2, there's what's called a feedback loop. If you ever heard of microphone feedback, you know how annoying that is, right? Same thing, feedback loop in the dynamic models. It was fun because I said the economists understood those models as dynamic models and the physicists knew them as differential equations. I couldn't help the historian. Anyway, does that answer it?
Yes, thank you.
You stop coal by 2030.
So Bruce and I are both members of an organization called the Citizens Climate Lobby. And it's an organization that is focused on a systemic government action solution, because we need everybody on board to solve this problem and to reduce coal. And so to not only reduce coal by 2030, but to bring down other fossil fuel use, we mentioned briefly about a carbon fee and dividend. And that's where you put a tax, like the European oil companies asked for. You put a tax on fossil fuels as they come out of the ground or into a port, and that increases the cost of those things, and that cost gets passed along to people, which is not a good thing. But you take all the revenue collected and you give it back to the people, and that's how we keep the people whole while the prices are going up. But then because the cost of fossil fuels are rising, and you might know that the cost of solar and wind are coming down and down, and the cost of solar panels, for example, have come down 90% in just the last 10 years. And they would get even more cost effective if the cost of fossil fuels were higher. So you use market forces to get us to use less of all of those things. This is the best way to go.
Remember, I said I was a conservative because I believe that market forces are the right way to get people to do things rather than just putting a rule out there. If you want to study how well that works, just look at prohibition. Over here?
I heard that we passed the global tipping point. What does that mean?
Right now, if we stop burning coal today, we'd still have a 2-degree Celsius increase by the end of the century because we're on a, even if we stopped releasing CO2 now, did away with fossil fuels, we've baked into the pie or into the cake an increase. So we've gone past that point. So I think that's what the tipping point would be.
And there are some scientists that have hypothesized that we might pass a point where things will be out of control and the feedback loops will keep us warming. But actually, in the United Nations, the IPCC report, they don't believe that there's much likelihood that there will be a tipping point into uncontrolled warming. So that's the good news. But we've got to get ourselves active to slow and then decrease CO2 emissions. Question up here?
No.
Wait, hold on here. Taylor.
Okay. So, like, what do you think the effects would be if Donald Trump and Scott Pruitt got what they wanted by, like, reducing, like, regulations for the environment?
Currently, we're a little bit challenged with the president and the head of the EPA that are denying climate change. But the good news is that there's such a tremendous reaction against it that we actually have more House Republican representatives joining the Bipartisan Climate Solutions Caucus. And they're working towards revenue-neutral carbon fee and dividend. And so we're hoping that perhaps in spite of our government, we can go where we need to go. Another good thing that's happening is that there's a international climate conference going on right now in Europe, and China and India are stepping up and saying, you know, if the US isn't going to lead, we will. So there's actually some stimulation maybe of other countries in really getting even more serious about it.
We have about a minute left, so I want to just say thank you guys. We have one more question. Let's give them a round of applause.